Without further ado, I'll be talking about GraphQL today. I came across this really great talk a little while ago. It's called Choose Boring Technology, and I really recommend you have a look. There's the URL at the bottom there. What Dan argues in this little article, and it's written up as an article on his site, is that there's often a lot of innovation that you want to apply to a new project. So you're looking to solve something in maybe an innovative fashion, so you can make money off the project or be successful with the project. But really, there's a finite amount of innovation that's available to you. So what Dan argues here is actually you shouldn't be applying the innovation to choosing the latest technology or the latest programming paradigm and trying out something brand new that has the high likelihood that you may hit an issue further down the line and hit some roadblocks when using that technology. Really, you should focus on using tried and true technology that you have experience with in order to really get the best out of your project. So that's really going to flavor how I talk about GraphQL today. I'm going to be giving a brief introduction to what GraphQL is. I'll be moving on to talking about what the benefits and considerations are for using GraphQL, using a little example of a little project I've been working on. And then I'm going to loop back after that and talk about whether it's boring. And by that I mean, is it worth using on a project? Is it kind of cemented in the space enough to be useful? And then right at the end, I'm going to do a little quiz just to check you've been paying attention. So make sure you keep your eyes peeled for that. So what is GraphQL? In a nutshell, I'd say it is a way to build flexible, predictable APIs. So it's kind of like a modern alternative to REST APIs, which is something you've probably seen. REST has been around for about 20 years now, so it's very highly entrenched in the space. But again, in a nutshell, GraphQL helps you take APIs and build a typed schema, so a nested schema. That's where the graph comes from, in that we are nesting these types inside of your API. So that's very much like what Harpreet was talking about a second ago. But by building this nested schema, you can allow your end users to kind of define their queries based on the schema rather than based on how you're presenting the data to them in a very concrete and kind of very static form in what would be built with the REST API. Now the word graph in there kind of confuses people a lot, so I like to just walk through some of the things that GraphQL isn't. First of all, it's not a graph database. So GraphQL doesn't handle storage of data, it doesn't handle resiliency or efficient querying of that data. It's kind of actually quite decoupled from graph databases, although I'll mention in a second how sometimes it can be applied to a graph database model. Next up, it is not a standardized query language. So GraphQL is kind of long, there's a few syllables there, so people like to maybe reduce that down to just the 3 letters GQL, but that's actually, it clashes with a few other query languages that exist, and GQL is actually a standardized language that's being proposed for inclusion in the future. So in itself, it is not a language for all graph databases. And in a similar way, it's also not actually a graph database querying language. Now, there's a little asterisk there because there are some graph databases who do use it, so there is an exception there. But it's not a kind of de facto query language for graph databases at all. So to walk you through why you might want to be using GraphQL, I want to walk through a little program I wrote recently, a little Twitter bot recently. I stumbled upon these great little bots online that are mostly written by the same person, I believe. But what they are is they take the weather from particular regions around the world and they convert it into little tweet-sized emoji maps, as you can see here. I especially like keeping an eye on the California one because it really does vary across the whole country. Sometimes you can see some really freezing icons on the top, and then at the bottom it can be quite warm, for example. So I recently moved to Vancouver Island in the west coast of Canada. So I thought it'd be neat to kind of recreate one of these, but for the island I live at. So what I did is I took the shape files, which is a kind of geographical description of the world. I took the shape files from the Canadian government and I isolated Vancouver Island. I then stratified that, I kind of split it up into these little squares before kind of sampling in the middle of those squares to get all of the lat-long coordinates I want to use for the island. And as you'll see in a minute, I had to reduce this down further because that's actually too many points for a tweet, especially in taking into account the indentation you need at the beginning of the tweet as well. So as with any good project, there's an API that underpins this. I chose the Dark Sky API, which is a really nice weather API. And they have a REST API. It's very comprehensive. What you do is you do a GET request to this URL with my key there. And then you also get a lat long results there. So you provide the lat long, sorry, and then it gives you the results in a really big JSON response, as you'd expect. Now for my Twitter bot, I would only actually need the icon and the temperature. So there's actually an awful lot that is returned from this endpoint when I do these requests. Now, this doesn't really matter when I do these tweets because there's not too many points here. We're not talking about thousands or millions or billions of points, but it is quite inefficient. Every time I'm running this every 6 hours, I have to request 100 JSON blobs, and I get those back, and I have to just throw away most of them, which is a bit of a pain. Now, for my little example here, and you can see it online at that handle there, that sort of volume, it's not really much of a problem. But whether it's down to performance for larger projects, or whether it's down to API restrictions, or not wanting to spend too much on maybe commercial APIs, this is really something you want to take into account when you're working with an API like this. Now, with the REST API, somebody's designed this at Dark Sky. It's very comprehensive, it's very nice. There are ways to maybe restrict the amount of data you return back, but a lot of that has to be designed and hard-coded. So it's by no fault of the API creators themselves that it's not quite as flexible as I want it to be for my use case. So that's where something like GraphQL would come in. And there's kind of an unofficial motto for GraphQL, and that is what you want is what you get. So what that means is I can actually just return the results I'm looking for. So in this really basic example here, I'm talking to a GitHub GraphQL endpoint. I'm querying with a parameter here, a variable here for a username, and I'm actually listing the fields I want to get back. So I'm getting my login, I'm getting the ID, I'm getting a URL there as well. You can also see here that I'm also have a nested repos part of this query here. And this looks like JSON, but it's not quite JSON. This is just GraphQL. Because I can do a nested request for all of the username repos here as well, there's actually fewer round trips required. I don't need to get the username and then send a new request to get the repos, and then maybe send another request to get the nested issues here. And you can also see that I'm also limiting, so I'm doing a nice simple limit to reduce the number of issues that I'm returning back for this repository. It's typed, so it's kind of safer and it's consistent. You know if you're going to be querying for a particular field, it's typed, so you know what to do with that in your application. And so you kind of guarantee that it's always going to be consistent when you do those queries in the future. And then finally, it has excellent tooling. I don't have too much time to talk about this today, but there's some great applications out there for doing nice querying right in the browser against these endpoints, which makes it really easy to prototype and think about what you actually want to return for your application, for your use case. Now, of course, there's always drawbacks, there's always downsides. These are things you should consider. I don't have too much time to go into these today, but the two that jump out to me, firstly, it's a different way of doing things from REST. So you might expect error codes from using HTTP from REST. You need to actually look at the result, because GraphQL endpoints will always return a 200 code. The other thing is, because each individual kind of user or consumer of an API will be requesting different data, different fields, etc., your caching isn't quite as neat on the server side, because if somebody requests the same thing, if two people request the same location for a weather API, for example, we can just send that data again. Whereas if you're limiting the number of fields, the fields you're choosing are probably unlikely to be the same as someone else's. Now, I've got some links there at the bottom of the screen. I definitely recommend reading those if you are considering to use GraphQL for your next project. So I want to finish up talking about GraphQL with a few considerations. The question here is GraphQL boring? Now remember, we want it to be boring. We want it to be sort of solid enough for us to choose for a project, so that we don't hit any sort of roadblocks along the way. So first up, the age. I think here's just a small list of considerations to make about things like a new programming paradigm like GraphQL. First up, age. GraphQL has been around since about 2012. It actually originated out of Facebook. So 8 years is a reasonably long time in technology nowadays, especially from the JavaScript space. And so I think that's a good amount of time for this to be a good application choice. Next up, owner. It originally came out of Facebook, but now there's actually a foundation set up to handle and to look after and sort of maintain GraphQL. I think whenever there's a sort of foundation or some sort of clear owner or maintainer, I think that's a good sign for the application you may be choosing to use. Ecosystem, there's a great ecosystem. There's a number of great companies that have been born out of using GraphQL. Apollo is the main one that comes to mind, but there's a lot out there who kind of pin the whole technology stack on GraphQL. And then finally, license. It kind of doesn't really matter in terms of technology choice what the license is, as long as it is compatible for your use case and your proposed kind of commercial model. The GraphQL license is open source at this point, so it is very permissive, so it's a great choice for a lot of applications. So in summary, I think it is boring. I think at this point it's getting to the case where it is a good choice for your building an API in 2020. Of course, there are caveats, and I would recommend looking at those links I shared before. But I give it a sort of boring stamp of approval from my perspective. So as promised, here's a little quiz. But before I get to that, there's a couple of further reading. I wrote these up for previous webinars, and they're kind of more related to the graph space, which is what we do at Cambridge Intelligence. So there's an example of using a GitHub GraphQL endpoint, like I kind of gave you a screenshot of earlier. And there's also the GraphQL and Neo4j integration here using what's known as the grant stack. So true or false? I haven't got too much time, so I'm not going to do this interactive. So please feel free to shout at your computer screen for each of these questions. First up, do you need a graph database to take advantage of GraphQL? True or false? I feel like if there's one takeaway from this talk, it should be that you do not need a graph database to take advantage of GraphQL. So that is false. They are effectively different technologies, although they are similar when it comes to the fact that they're talking about graph nested data. Next up, GQL and GraphQL are names for the same thing. It's so tempting to just truncate GraphQL down to a GQL, but there are a few other things that will collide with, so it is a bit confusing. So they are not the same thing. This is false. Number 3, a downside of GraphQL is it requires more round trips when querying an API. Again, this is probably quite simple, really, but that is not true. There are actually fewer round trips required with GraphQL because you can basically encode more in a query and get more nested results back from the API. And then finally, GraphQL is boring. True or false? I'm afraid this is a bit of a trick question. I think it's boring, but really it's up to you and your technology choice for your application, whether it's suitable for your use case. It is boring in some sense of the word, but really, you always want to take care about what technology you're choosing, especially if you're working day in and day out with those for the foreseeable future. So thanks again for your time. I'm Christian Miles. Feel free to follow me on Twitter, or I have a graph newsletter called Source Target. There's the website for that. But without further ado, I'll hand back over to Kevin to talk to you about React development.